So these are the problems that you want to kind of take your time and be careful on. Make sure you're getting the right values of where they're supposed to go. When it says, will anything precipitate, that is one of these ones where we need to do a reaction and we got to look up K values, and there's a bit involved with these. So the first problem, I'm mixing PbNO3 with NaBr. And that gives me PbBr2 plus NaNO3. And I know that because I know that that's a -1 and that's a +1. And then since I had needed 2 of those, that means that my PB was a +2, and so I maintain that +2. Like those transition metals, when these double displacement reactions, they maintain that same charge throughout. That's just what they do. But even if you weren't sure, when you started looking at the list, you probably would have been like, oh, I bet that it does need a 2 in front. So I'll tell you, anything with an alkali metal or a nitrate, it's aqueous. So I can see that's going to probably be R1 to look up. But if you're not sure, look for sodium. You won't find anything. And so that'll tell you, well, it should be the lead one. So here's lead. And lead bromide, I'm putting it at the top, is 4.6. So the KSP for lead bromide is 4.6 times 10 to the -6. Now, note, I'm only using this for comparison. I am not using this to like do an ice chart where I like solve for X for it and stuff like that. I'm doing something a little different with how I'm solving for that. I am going to go ahead and write down the other reaction since I've got this chart pulled up though. So again, PbNO3 2 plus NaCH3COO minus becomes PbCH3COO minus and NaNO3. Now if you'll look over here, again, this is AQ. And I don't know if you remember this, but acetates also are always soluble. But let's take a look at it. So here's our lead. You'll notice that CH3COO, it's not anywhere in that list. And we're going to be giving you stuff that's in the list. Or like it's not going to be like one of those, oh, well, it's in some other list somewhere. It's not going to be that kind of a scenario. So that's going to be also AQ. So look, this problem was here for the sole purpose of pointing out that you have to have a solid in one of these to get a solid. And if both of those are AQ, this goes way back to Gen Chem 1. When you break this all up, like if you break it into ionics, like Pb plus 2 and 2 NO3 minuses and Na plus and CH3COO minus, when you break it all up, they're all going to cancel and it's going to be a no net reaction. So you have got to have a solid to solve it. So I'm going to go back and I only really have to solve this one in here. And I'm going to move this out of the way. So I am going to basically figure out the QSP. So I'm going to write PbBr2, that's a solid. It breaks into Pb 2 plus and 2 Br minuses. And again, those are AQs. Now, for the amounts, the whole reason that I wrote this like this was because I just need that, I need the Q expression. And I think it's easier to see it like this. But you might be getting good at it and being able to be like, oh, there's 1 ion and then there's 2 and we're good to go. So you might be wanting to jump to that step, but hang on. I need to actually write them in because they don't have the same X value. You'll see what I mean in a second. So there's our QSP expression. That's the whole reason I wrote that out. I'm not trying to go all into crazy ice chart land. But I do need this value and I need that value. So I'm going to get the PB1 from that mixture. I'm sorry, I did the wrong. From this mixture. That's where I'm getting my PB from. And then my BR is going to be coming from that mixture. So I have 100 milliliters of this. So I'm going to, of 2.0 times 10 to the minus 2. So for the PB, I'm writing it as 0.100 liters instead of milliliters. And then in 1 liter, the moles, 2.0 what was it? Times 10 to the minus 2. That's going to give me moles of that number. Now note, that's a bracket, so I still do have to get those in molarity. Just hang on 1 second. When I multiply that, that's going to give me 2.0 times 10 to the minus 3 moles of Pb. Now, for the Br, I'm going to write that as 0.150, and then there's my molarity, 1.5. 0.150 liters, 1.5 times 10 to the, it's just 1.5. There's no times 10 to the, and then that's moles per liter. So that should be like a 225 number, but I'm going to go ahead and type it in, 0.15. There we go, 0.225 moles of Br. Now, all we have to do is figure out the new total volume. So look, I'm taking this volume and this volume. So 100 and 150 gives me 250 milliliters, which is the same thing as 0.250 liters. That's my new volume. So that number divided by 0.250 liters, this number divided by 0.250 liters will give me my new molarity. Come on, calculator. So I will do the 225 first because I've already got it in there. 0.250 gives me 0.9 molarity. And then the other one, 2e to the minus 3 divided by 0.250 gives me 0.008 molarity. I'm putting those two numbers into my QSP up here. So my QSP becomes 0.008 times 0.9 squared. So I've got that number times that number squared. Gives me 6.48 times 10 to the negative 3. Here's the big deal. I'm going to compare K to Q, and you can see that's times 10 to the minus 6, that's 10 to the minus 3. So it looks like this. Hopefully you can see that. That's a number like that. That's a number like that. So this is a bigger number. So that means that my equilibrium is going to shift towards the solid side. I will have a precipitate.